Okay, good morning everyone. Today my group, Catherine, Ileana, Natalia, and me, John Michael, will be presenting on our topic of periods, groups, and blocks on the periodic table. Okay, so first things first. We will explore the properties of the periodic table and how it is organized. You, as the student, will complete guided notes about the periodic table, do a short activity, and take a short quiz at the end to show your understanding of what you learned. And for our essential question, how is the periodic table organized into periods, groups, and blocks, that being S, P, D, and F, which we will talk about later? And where are metals, nonmetals, and metalloids located?
This is going to be a warm-up activity. It's 2 questions and it'll be 5 minutes. One question is, what determines an element's period number and block? And the second question is, why is helium placed in group 18?
So to introduce our topic, we will be discussing the periodic table and its arrangement. This arrangement can help you know the elements and their properties in relation to each other. We'll provide you fill-in-the-blank notes, so on each side there's a red underlined word and you would just fill that in.
Okay, going on to periods. Periods are the horizontal rows on the periodic table. They indicate the number of energy levels, such as like electron shells, that an atom may have. An example of this would be elements in period 2, as they have 2 energy levels. There are a total 7 periods or rows on the periodic table. As you move left to right across the periodic table, they increase in atomic number, meaning more protons, gradually changing from metals, metalloids, and nonmetals.
Okay, so next up is groups. Groups are vertical columns that indicate the number of valence electrons. So for example, nitrogen is in group 5 and thus has 5 valence electrons. Elements in the same group also share similar chemical properties and reactivities. So xenon and argon are both in group 8 and have similar reactivities and chemical properties. The groups on the periodic table are as follows: alkali metals in group 1, alkaline earth metals in group 2, the transition metals from groups 3 through 12, boron group in group 13, carbon in group 14, nitrogen in group 15, oxygen in group 16, halogen in group 17, and our favorite ones, noble gases, in group 18.
When talking about the block structure, we're talking about 4 different groups, which is S, P, D, and F, and it's talking about the electron configuration and the reactivity that ties into it.
Metals are typically found on the left side of the periodic table, and a lot of this is due to the fact that they have less valence electrons and a larger atomic radius on that side, so they're further from the nucleus, so therefore it's easier to lose electrons. This is in comparison to nonmetals, which are more likely to gain electrons because they have more valence electrons. Properties of metals include like high conductivity, a high melting and boiling point, and that they're malleable and ductile.
Going on to nonmetals now. Nonmetals are usually found on the right side of the periodic table, plus hydrogen on the left. They have a little conductivity, meaning they don't transfer heat or electricity well, unlike metals. They tend to have low melting and boiling points, so many are gases at like room temperature, like oxygen. When solid, they are brittle, meaning they break easily instead of bending. They are usually dull, they're not shiny. Nonmetals are pretty essential to life. Example of this would be oxygen. Oxygen is needed for breathing, and carbon is the basis of all living organisms. In chemical reactions, nonmetals gain electrons, forming ionic bonds, or share electrons, forming covalent bonds. They have more valence electrons, usually 4 to 8, which is why they tend to gain or share electrons instead of losing them.
By far the smallest group on the periodic table are metalloids. Metalloids are elements with both properties of metals and nonmetals. They're located between the metals and the nonmetals, and they're semiconductors, meaning that they can conduct heat and electricity, but not as well as a metal, though they do it better than nonmetals would.
Now we're going to be going into the peer practice.
This activity, we will be doing a think, pair, and compare, and we will be providing questions, and you will answer and discuss this with your group members or the people next to you. So pause the video for maybe about 2 to 3 minutes and answer.
Back to part B, number 4 states, why do D block elements often show multiple oxidation states? Because both S and D elements can participate in bonding. Why? Now to number 5, why are F block elements separated from the main table?
Part A, your answer to the first question will be B, the P block. This is because the last electrons fall in the P subshell, so therefore it belongs to the P block. Number 2, your answer will be C, D block transition metal, and this is because the last electrons land in the D subshell, which is also where the transition metals are. For 3, the answer should be C, because the max electrons in the P subshell is 6. So if it were to gain 1 more electron, then it would fill in that subshell.
Back to part B, number 4 states, why do D block elements often show multiple oxidation states? Because both S and D elements can participate in bonding. Why? Well, the D block elements, such as the transition metals, have electrons in both the outer S and the inner D orbital. Because of these electrons are so similar, they are easy to lose an atom differently. So it's easy for the atom to lose different numbers of electrons. Because of this, both S and D electrons can be used in bonding, leading to multiple oxidation states. Now to number 5, why are F block elements separated from the main table? The answer is because they would make the table too wide. The F block elements, which I can't really pronounce too well, are placed at the bottom because they keep the elements in the periodic table more organized and readable. The table would be just far too wide, and it's not too much to elaborate on that one. And now for a quiz time with a hamster, yippee!
Okay, so now we're going to start our quiz. Part A, you're going to independently answer these questions. Number 1, the S block consists of groups 1 and 2, groups 3 through 12, or groups 13 through 18. Number 2, Ne3S3P is in A, period 2 S block, B, period 3 P block, 4, period 4 P block, or D, period D in D block. And 3, which configuration represents a transition metal? A, 1s2, 2s2, 2p6, 3s1. B, Ne3s2, sp6. C, Ar4s2, 3d6. Or D, 1s2, 2s2, 2p5.
This is part B, which is an independent practice, and this will be 3 minutes. It's time for the answers, so make sure you look back and correct anything that you need to.
Okay, the answers to part A, the independent questions are, for number 1, the S block consists of A, groups 1 and 2. For number 2, Ne3S3P is in B, period 3 P block. And number 3. Which configuration represents transition metals? C. AR 4S 4S2 3D6.
The final answers will be B and C. So if you got it incorrect, make sure to group discuss. And if you have any questions, then let us know.
What we've been learning today, the periodic table is organized from increasing atomic number, and it consists of periods and rows. It's organized into different blocks such as the S, P, D, and F blocks, and this is based on the sublevel of valence electrons. It's also organized into metals on the left side, metalloids in between, and nonmetals on the right side.
Okay, and now we have Sir Squidiums to teach the non-metals because he's my mentor and he's great. He's so great.